this exercise, question 812. We have been given one triangle, and in that triangle, we are supposed to find out the difference between tan, which is tangent ratio, and cotangent, which is the cot ratio of two different angles. Let's see the diagram first. This is the right angle triangle with P, Q, and R are the vertices. In this one, the altitude PQ has been given as 12 centimeters. The hypotenuse is given as 13 centimeter, but we are not given this QR, which is the base. So according to Pythagoras principle, we have to first find out the length QR. We know that PQ square plus QR square is always hypotenuse square. So we can calculate the square of this side as the difference between those two squares, and then QR will be the square root of those two differences. So let's say that can be calculated as 13 square minus 12 square, and then take the square root. That would come out to be 169 minus 144, and the answer will be, after taking square root, will be 5 centimeters. So once we know all three sides, we are ready to calculate any trigonometric ratio as required. So let's start with tangent of P. The focus will be on angle P. Now, for any right angle triangle, the longest side will be always hypotenuse opposite to the 90 degrees. So 13 centimeter will be hypotenuse irrespective of whichever angle you are considering. But the other two definitions will depend upon what angle you are considering. Here we are considering angle P. So this QR will be directly facing in front of it. So that would be opposite. And the third remaining side will be always adjacent. So now these definitions are also well known. So we can actually calculate the trigonometric ratio. We have been asked tan P. First, I will concentrate on tangent of P. That would be, according to the definition of tangent, it's always opposite over adjacent. Opposite for P is 5, we have just calculated, and adjacent is 12. So the tan P has been evaluated as 5 by 12. Now let us repeat that process and focus on cotangent of R. Let us copy paste the same diagram. Now the focus is on angle R. However, the hypotenuse still remains as the same side, but for R, PQ, which is directly facing in front of it, so PQ will be opposite and QR will be adjacent. Now, I know that we are actually calculating cotangent, but this is one of the reciprocal ratios. Remember, there are 6 ratios. The 3 basic ratios are sine, cosine, and tan, and the 3 reciprocal ratios are reciprocal of sine is cosec, reciprocal, which is 1 over, reciprocal of cos is sec, and reciprocal of tan is cotangent, which is cot. So even though I want cotangent, cot, first I will evaluate tan for that particular angle and simply take the reciprocal. Now we know that the tangent definition we have already seen here. Tangent of R is opposite over adjacent. So first I will evaluate tangent. So that will come out to be 12 over 5. Now actually we want cotangent, cot. Cot and tan are related, simply reciprocal ratios. So cotangent R, cot R is 1 divided by tangent R, and that will be simply flip the numerator with denominator. It will come out to be 5 over 12. Now we are ready for evaluation of this expression. I will write that expression separately. Tan P we can take from 5 over 12. Cot R coincidentally came out the same way, 5 over 12. So the difference between them after substitution will be simply 0, because tan P and cot R came out to be same. So the final answer will be 0.